In this video, let's try to understand what we mean with the complement of an event. And many times we'll be asked to find the probability of the complement of an event. Let's take an example to understand this. Say you're rolling a dice, alright? And let's define event E as getting an even number. So that could be getting 2, getting 4 or getting 6, right? Now the complement of this event E can be noted as E dash. That would be not getting an even number. That is, E dash is all the events where E is not satisfied. Now we can notice that either E will happen or E will not happen. There is nothing else in between, right? Therefore, the probability of E happening plus the probability of E not happening is equal to 1, because either of these definitely has to happen, right? You will either get an even number or you will not get an even number. So that could be the case with anything. If E had been defined as getting the number 3 when you roll the die, E dash would be not getting 3. So either you get 3 or you don't get 3. In this case also, the probability of event plus the probability of the complement of the event would be equal to 1. Therefore, we can find out that the probability of not getting the event is equal to 1 minus the probability of getting the event. Alright, now what is the probability of getting an even number? We have seen that that's the probability of getting either 2, 4 or 6. So you have 3 favorable events out of a total of 6 events. So the probability of E will be 3 by 6, right? And that's equal to 1 by 2. Now, it so happens that not getting an even number is the same as getting an odd number, but it's not always the case, right? Now, PE dash would be equal to 1 minus P of E, which is equal to 1 minus 1 by 2, which is equal to 1 by 2. That is, the probability of not getting an even number is equal to 1 by 2. Now, in many cases, it's possible to calculate either the probability of the given criteria, or you could find the probability of not getting the given criteria and you can do 1 minus P of E dash to get PE. Now in many cases this approach will give you the answer much faster. We will see that in some example questions. Now let's quickly visualize what we have learned over here. Let's say that this is the universe of the events, alright, and let's say we have an event A. So this would be the cases where event A is happening. Now all the cases where A is not happening in this universe, that is this area over here, is what we define as the complement of event A, which is denoted as A dash. Let's do this question. When rolling 2 dice, what is the probability of getting the sum as 10 or less? Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Over here, 2 dice are rolled, right? So in each die, you can get any of the outcomes, that is 1 up to 6. So the least sum you can get is 1 plus 1, which is equal to 2. And the greatest sum that you can get is 6 plus 6, which is equal to 12. Now, we need to find the probability of getting the sum as 10 or less, right? So that would be the probability of getting the sum as 2 or 3 up to 10, right? So one way of solving this question is we can find each of these probabilities. That is the probability of getting 2, the probability of getting 3, 4, 5, 6, 7, 8, 9 and 10. And then we can add up all these probabilities. That is one way of solving this question. Another way is we could find the probability where this event, which is P of E, does not happen, and we can do 1 minus that event. That is 1 minus probability of E dash, right? And what is E dash? That is when the sum obtained is not less than equal to 10. And what are those cases? It could be 11 or 12. So this over here, 1 minus P of E dash is equal to 1 minus probability of getting 11 plus probability of getting 12. So we can see that this approach saves us much more time because we just need to find 2 probabilities. Alright, let's see the case where we obtain 11. So we have 2 dice over here Now to get a sum of 11, I could get 5 on the first one and 6 in the second one, or I can get 6 in the first one and 5 in the second one. That's two outcomes, which gives me a sum of 11, and therefore the probability to get a sum of 11 is 2 divided by the total number of outcomes, which is 6 into 6, right? Because in the first die I can get 6 outcomes, in the second die I can get 6 outcomes. That's 1 2 3 4 5 6, right? Therefore in the first die and the second die I can get 6 into 6 outcomes. So in 2 out of 36 outcomes, the sum will be 11. What about 12? There is only one possibility with which I can get a sum of 12. That is, in both the dice, I should get the outcome as 6. So there is just one way in which this can be done, and therefore the probability to get 12 is 1 by 36. And therefore the answer to this question, as per what we have written over here, is 1 minus 2 by 36 plus 1 by 36, which is equal to 1 minus 3 by 36, which is equal to 11 by 12.